All right, recording. Okay. So, hello, we are going to finish 2015. We're going to do questions 5 and 6. All right. And I think, these are really good problems. Number 6 is, again, a sequence and series question. I think that's more so like the kind you might see. So, we're going to actually try to attempt that one and see what we can do. Okay. All right. So let's start with number 5. It says, consider the function f of x equals 1 over x squared minus kx, where k is a non-zero constant. And if I were to take the derivative of that, it would be k minus 2x over x squared minus kx to the second power. So they've already taken the derivative for you. You don't have to do that process. And in case you're curious and just want to see, f prime of x is equal to, remember, this is the same thing as having like x squared to the minus kx negative first power. So if I were to take the derivative of that, it would be negative x squared minus kx to the negative second, and then times the derivative of the inside, which would be, um, that should be x right here, I'm sorry. That would be 2x minus k. Which if I were to distribute the negative and bring the negative power to the bottom, this would be equivalent to k minus 2x over x squared minus kx to the second power. So you can see that is indeed the derivative. You just don't have to find it now, okay? In case you're wondering where that relationship came from. All right, so let's start off with part A. It says let k equal 3. All right, so that means that we have f of x is 1 over x squared minus 3x now. And it wants us to write an equation for the line tangent to the graph of f at the point whose x coordinate is 4. All right, I don't care what the question is and what context we're in. If it says line tangent, we need a few things. We need a point, okay, and we need a slope. Those are the things we need. Let's start with the point. With the point, okay, we know the x value is 4. We know the x value is 4. If I want to know what the y value is, we need to plug 4 into this equation. So it's going to be 1 over 4 squared minus 3 times 4, which would end up being 4 comma, that's 16 minus 12, so 1/4. Okay, 4 comma 1/4. Now, the other thing we need is the slope. Okay, well, so we got the derivative up here. We just need to plug 4 in for x and 3 in for k. So f prime of 4 is going to equal k minus 2x, so that's going to be 3 minus 2 times 4 over, and then it's x squared or 4 squared minus k, which is 3 times 4 quantity squared. Okay, so all I did was plug in the 3 for k and the 4 for x into that derivative function. That ends up being, see, negative 5 over 16. Okay, so we got our point, we got our slope, now we have our tangent line. So it's just going to be y minus y, or y minus 1/4, equals my slope, negative 5/16, times x minus my x value, 4. So there you have it. That is the equation of a tangent line. Pretty straightforward, I think. All right, let's try B. So now k is 4. All right, so that means that my f of x is 1 over x squared minus 4x. So we're going to determine if f has a relative minimum, a relative maximum, or neither at x equals 2. We're going to justify your answer. All right, we have a max, a min, or neither. We justify that by looking at the derivative. Okay, so what we're going to do is we're going to first of all think about, all right, what happens if I plug 2 into the derivative? Is it going to be a critical point? Is it going to be equal to 0? So I think that's a good place to start. So let's start by finding f prime of 2. Okay, so like for instance, if I plug 2 in for x and 4 in for k, I got 4 minus 2x, or 2 times 2, over, and the bottom is going to be x squared, which is 4, minus kx, which is 4 times 2, quantity squared. Okay. And if you see, the bottom is actually not going to be 0, but the top is going to be 0, so f prime of 2 does equal 0. So I can go ahead and eliminate the fact that it's neither, because it is, well, I guess I can't really yet, so actually scratch that. I still got to test to see if it changes directions. But I know that it is possibly going to be a relative min or max. Okay, so I don't want to find the second derivative, so let's just do the first derivative test. Let's plot that point on my number line. So we're going to put 2 right here. And this is doing f prime of x. We're going to test some points. Let's take test 1 and 3. So if I plug, well, let's write it out real fast. F prime of x is equal to, k was 4, so it's 4 minus 2x over x squared minus 4x squared. Okay. So if I test some points in that, like let's say I test 1, then that's going to be a positive value right here. You can test out 1 and see. The number's always going to be positive on the denominator because it's squared. On top, if I plug 1 in, that's 4 minus 2, which is positive. If I plug like 3 into that, that's 4 minus 6, which is negative. Okay. So at this point, it's going from positive to negative. So since f prime of x changes from positive to negative at x equals 2, then x equals 2 is a max. Okay, so that wasn't too bad. That was just going along the first derivative test, pretty much. Okay. All right, let's try C. C says find the value of k for which f has a critical point at x equals 5. Okay, so what does it mean to be a critical point? It means if I plug negative 5 in for x, then the function, then the derivative is going to equal 0. That's what makes it a critical point. So what I'm going to do is I'm going to say, all right, if I did f prime of negative 5, f prime, so if I plugged in negative 5 in for x, I would have k minus 2 times negative 5 over negative 5 squared, which is 25, minus k times negative 5 quantity squared. Okay, and that has to equal 0 in order to be a critical point. All right. So if a critical point makes my derivative equal to 0, then all we have to do is consider the top part of my function. So I'm going to say k plus 10 equals 0, and thus k would have to equal negative 10. All right. And honestly, that was it. So there you go. We got a critical point, makes our derivative equal to 0, so I plugged in negative 5 for x, and I just solved for the k value that makes that happen. All right, cool. And lastly, D says, let k equal x, or k equals 6, so that now f of x is 1 over x squared minus 6x. We want to find, the partial fraction decomposition for the function f, and then find the integral. All right, well, if I'm finding a partial fraction decomposition, we've done that a bunch. We're going to say that this is the same thing as, so f of x equals 1 over the quantity x times x minus 6. Okay. And remember how partial fraction decomposition works? This is like saying like a over x plus b over x minus 6. Okay. All right. So we're going to have to solve that out. Remember how this works is like we're going to multiply everything by x times x minus 6, and it's going to cross some things out. So it actually simplifies down to 1 equals a times x minus 6 plus b times x, right? Because the x minus 6 cancels out with b, and the x cancels out with a. Okay. This is when we let x equal something, so I'm going to start off by saying let's let x equal, I don't know, 6. Okay. So that's going to cross out the a, and I'm left with 1 equals b times 6, so b is equal to 1/6. And if I let x equal 0, that's going to cross out the b, and I'm left with 1 equals a times negative 6, or a is equal to negative 1/6. Okay. So now how this decomposes, I'm going to plug 1/6 in for b and negative 1/6 in for a. So f of x, what I'm really doing is the integral of a over x, or negative 1 over 6x plus 1/6 over x minus 6, or 1 over 6 times x minus 6 dx. Okay. Because remember, if we have a fraction on top, doing the same change flip is going to get it to the bottom like that. Okay. And now, guys, all it is just going to be, it's like negative 1/6 times 1 over x. Like if I integrate that, that's just going to be negative 1/6 ln absolute value of x plus 1/6 absolute value x minus 6 plus c. And there you have it. That's the integral. That's the integration of f of x. We don't have to solve for c. It's just asking for like a general antiderivative there. There is no x value really to plug in. So I mean, I'm cool with this answer right here. If you look at the answer key that we're about to look at in a sec, they actually have it as well. They took out a 1/6 and combined it as ln of x divided by x minus 6. Or times. I'm sorry, but I chose not to do it that way. Actually, I'm sorry. They switched these two and made it subtraction and then divided it. But you're fine with leaving it this form right here. Okay. All right. So let's look at the answer key. There we have it. We got the slope for the first one was negative 5 over 16. We got the tangent line. They solved for y, but you do not have to. For b, they considered f prime of 2 and showed that it equaled 0, so we're good there. And then my answer with justification, and that was using the sine line explanation for the first derivative test. C, they took the derivative and plugged in negative 5 and solved for k when it equals 0, and that was negative 10. And for D, they gave you 2 points for the partial fraction decomposition. So for getting down to here, they left the fractions on top, but we don't have to. And then the general antiderivative, which we left it like this, and that's fine. But like I said, they went ahead and kind of rearranged it and made it to where it was subtracting 2 natural logs, and they turned it into division. But I think you're fine with leaving it undivided like that. All right. So I've seen a problem like that show up a couple of times where they give you a k value that k is constantly changing per problem. So it was a good question. They asked a lot of good things. But yeah, let's go on to number 6. All right, number 6, Maclaurin series. So it says the Maclaurin series for a function f is given by some general formula here. Okay, it's negative 3 to the n minus 1. It's kind of interesting. Over n times x to the n. And it's giving us the first 3 terms and the general term, which is from the summation. And it's saying that this is going to converge whenever the absolute value of x, notice because the center is at 0, it's just absolute value of x, whenever that's less than r, where r is the radius of convergence for the Maclaurin series. Part A says use the ratio test to find r. Now, again, I told you before, ratio test, you're probably only going to have to use it to determine if something converges or not actually find r, but it's the same premise, the same idea, so I think this is great practice. Okay, so let's practice it. So remember how ratio test works. It's going to be the limit. It's going to be the limit as n approaches infinity of a sub n plus 1 over a sub n, okay, which is equal to the limit as n approaches infinity, absolute value of. Now here's the thing. Remember how I said with an alternating series piece, and you can see the alternating series here with -3 to the n minus 1. Remember how I said like absolute value, we're doing absolute value so you can ignore the alternating series piece? Well, that was because it was -1, and -1 becomes +1, and multiplying by +1 doesn't affect anything. But now it's -3, so I'm actually going to keep that in there, okay? Because multiplying by 3 is going to actually affect it instead of multiplying by +1, okay? So I'm going to do a sub n plus 1. I'm going to say instead of -3 to the n minus 1, I'm going to say -3 to the n plus 1 minus 1 is just n. I'm going to have x to the n plus 1 over n plus 1. And again, I'm going to leave the -3 in there because it's not like having -1 that just goes away. Multiplying by the absolute value of -3 is going to actually do something, okay? And then multiply by, same change flip, I'm going to do a sub n, just reversed. I'm going to have n on top, and on bottom I'm going to have -3, -3 n minus 1 times x to the n. Okay. Now it's still all going to simplify the same way here, like x to the n and x to the n plus 1 becomes x on top. -3 to the n and -3 to the n minus 1 becomes -3 to the negative first on bottom, which negative first power is just going to bring that -3 to the top. So what this actually simplifies down to, I'll do it right here, is the limit n approaches infinity of, on top we're left with, so the -3 goes to the top because the negative first power. Bless me. So we actually have -3 x and n on top, so -3x n, and on bottom we have n plus 1. Okay. Now if I take the limit of n, okay, notice how we have n to the first and n to the first, so we're going to take the leading coefficients when I take the limit, and that's -3x over 1. So the limit of this is actually going to be the absolute value of 3x, and I'm trying to solve for that's less than 1 because that's where it converges. Now, if I'm trying to set it up in this form here, the absolute value less than r, well, the absolute value of -3 becomes +3, so this is 3 absolute value of x less than 1, and now we just divide by 3, so absolute value of x is less than 1/3. Okay, so my radius of convergence is 1/3. So what I'm saying is that this particular Maclaurin series is going to converge to some sum whenever my x value that I plug in is between -1/3 and +1/3. Okay, and that's going to be true throughout the rest of the problem. It's going to be true whenever we have the derivative or anything like that. Okay. All right, so that was part A. Part B says, write the first 4 non-zeros terms of the Maclaurin series for f prime, the derivative of what we were originally given, and I want you to express f prime as a rational function. That's going to be interesting. We're going to express f prime as a rational function for whenever absolute value of x is less than r, which in this case we know r is 1/3. Okay. All right, let's start with the derivative first. So it's kind of weird because it gives us the first 3 terms and we need the first 4 terms. So let's start off with f. F is, it tells me the problem is x minus 3/2 x squared plus 3x cubed. And if I want to know the 4th term, because I got to go the 4th term for the derivative, I actually need to use my general term to plug it in. So I'm going to plug in, we started off with the first term. So I went first, second, third. I need to plug in 4 into this function right here to figure out my 4th term. So that's going to be -3 to the 4 minus 1, or -3 to the 3rd power, which is -27 over n, which is 4, and x to the 4th. Okay, so those are my 4th terms. It only wanted me to do the first 4 terms, but just for the heck of it, that's going to be plus ... -3 to the n minus 1 over n x to the n. Okay. Now, if I take the derivative, if I get my first four non-zero terms of the derivative, f prime of x, okay, it's the derivative of each of these four terms. So the derivative of x is 1. The derivative of 3/2 x squared becomes 3x. The derivative of 3x cubed becomes 27x squared. This becomes 27x to the third. Oh, what am I saying here? I knew something didn't look right. 3 times 3 is 9, not 27. So 9x squared minus 27x cubed plus plus. If I take the derivative of the general term, power rule says bring n down and the n's cancel. So I'm left with negative 3 to the n minus 1 times x to the n minus 1. Okay. So there's my derivative to the first four terms. It didn't ask for the general term, but I wrote it anyway. And it wants me to write this as a rational function. Okay. When do I have a rational function? Okay. When have I seen a rational function representing a series? How about in the form 1 over 1 minus some quantity, right? The thing is what they wanted you to recognize here is that, okay, 1 minus 3x plus 9x squared minus 27x cubed, that looks a lot like a geometric series. And if it is a geometric series, then I can write it as a rational representation. I can write the infinite sum along the interval of convergence. We learned that. So let's just make sure. Negative 3x divided by 1 is negative 3x. 9x squared divided by negative 3x is negative 3x. Negative 27x cubed divided by 9x squared is negative 3x. If you recognize this, there is a common ratio. The common ratio is negative 3x, so this is geometric. So if I wanted to represent this as a rational function, we can use the form a sub 1 over 1 minus my rate, which in this case is going to be a sub 1 is 1 over 1 minus my rate of negative 3x, which equals 1 over 1 plus 3x. So there's the rational representation of my derivative, because I know that this sum is going to converge to that because it's a geometric. And this is only true whenever x is less than 1/3. The absolute value of x is less than 1/3. Okay? So I don't think this part in red, finding these terms, was anything difficult, but making the connection that, oh, this is a geometric series, therefore I can represent it in this rational form, that's kind of what it was going to want you to go for. Okay. All right, then lastly, C says, okay, this one's a little bit confusing. It says, write the first four non-zero terms of the Maclaurin series for e to the x. Now, there you go right there. You should be very, very thankful if that question comes up with one of these questions, because you have memorized cosine of x, the Maclaurin series for cosine, sine, e to the x, and x to the n. You should, at least. So there's a guaranteed point right there just for writing down the first four terms of the Maclaurin series for e to the x. So remember, e to the x is equal to, it is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And only one of the first four terms, but remember the general term was x to the n over n factorial. All right, that's the pattern for e to the x. So that infinite sum gets you to e to the x. Okay. Now, that's the point. Now, it says we're going to use the Maclaurin series right here that we just got to write the third degree Taylor polynomial about x equals 0, so really a Maclaurin series, for g of x. Which g of x we're going to say is e to the x times f to the x, or times f of x. Okay? So, g of x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. It's equivalent to this e to the x times f of x, which is x minus 3/2 x squared plus 3x cubed dot 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 on forever. Okay, so that's what g of x represents. Now it wants me to approximate or write g of x as a third degree Taylor polynomial, meaning I only need to go up to the third degree. Okay, so though both of these series goes on infinitely, there's no point in looking at the fourth, fifth, sixth, and seventh terms because I'm only going up to the third term. So all we have to do is figure out this product up to the third degree, and then that's going to be the third degree Taylor polynomial for g of x. So I'm going to multiply this out. I'm going to distribute these values, but only until I get up to the third degree. So for instance, like I'm going to distribute. I'm going to do 1 times all of these numbers. Okay, so I'm going to do 1 times x, 1 times negative 3/2, whatever. So if I do that, 1 times x is x, 1 times 3/2 x squared plus 3x cubed. All right, now I'm going to times everything by x. I'm going to do x times x times 3/2 x squared, x times blah, 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 blah. That's going to be plus x squared minus 3/2 x cubed. Hey, if I did x times 3x cubed right here, well, that's actually going to make us go to the fourth power, so I don't need to do that anymore. Okay, I don't need to go to the fourth power. I'm only going to the third degree. So then I'm going to do x squared over 2 factorial times x, which becomes x cubed over 2 factorial. Okay. And then I don't need to multiply this by the x squared term because that's going to be x to the fourth power. And I don't need to multiply this by any of these terms because that's going to be at a power greater than 3. So if I multiply out these quantities, this is as far as I need to go because that's the highest the powers are going to go to. Okay, is to the third power. Any distributing past this is going to be x to the fourth, fifth, and sixth, which is not where I want to be. So if I simplify this down, I'm going to do all the x terms first. So there's only one x term, and that's just x. So I'm going to say x. What are all my x squared terms? I got one right here. That's negative 3/2 x squared and positive x squared, which becomes negative 1/2. Let me make sure. Yeah, negative 1/2 x squared. And then finally my cubes, I got 3 cube terms. So that's 3 minus 3/2 plus 1/2, which is going to be 2x cubed. Yeah. And that right there is my third degree, because I'm going to the third power. That's my third degree Taylor polynomial centered about 0 that represents e to the x times f of x. You see, we've had questions like this before where they have you take pre-existing Maclaurin series and you're building on it. Here it was just a kind of a weird build that you had to do, but it was only up to the third degree. Okay, so there you have it. That's the answer. So for A, we set up the correct ratio. I feel like we've gotten really good at the ratio test. We set up the correct ratio. We computed the limits of ratios, so it came down to 3 times the absolute value of x, and then we figured out that the radius of convergence was 1/3. For part B, we did the correct 4 terms for the derivative, and then we recognized it was geometric, so we could create a rational function using my convergence for geometric, a sub 1 over 1 minus r. And then for C, we found the first 4 non-zero terms for e to the x. So if you had no idea how to do part C, you could have gotten 1 out of 3 points right there, though, just for knowing e to the x. So it's really important to know that. And then 2 points for the Taylor polynomial. So that's taking e to the x times f of x only to the third power, though. Okay. And then they classified it as t sub 3 of x. I don't think you have to, but we got the answer to be x minus 1/2 x squared plus 2x cubed. All right, and that does it for year 2015. 2016 will all be uploaded for us next week, starting Monday. All those will be uploaded on Monday. So you can spend all of next week just kind of doing that. All right. Well, good luck, guys. And if you have any questions, please let me know. And we are under 30 minutes, baby.